another grain of coffee, and raised her eyebrows by the breadth of another line. The last of the three now said his say, as he put down his empty drinking vessel and smacked his lips. Ah, so much the worse. A bitter taste it is that such poor cattle always have in their mouths. Hard lives they live, Jacques. Am I right, Jacques? You are right, Jacques, was the response of Monsieur Defarge. This third change of the criminal. Mm. Hi, Gina. I think you're there.
Hello?
Hi there.
Oh, hi.
And is it Gina or Gina Lee?
It's just Gina. That's my full name.
Hi, Gina.
Hi.
So my name's Dave Kukla, and I hear you need some help with geometry.
Yeah.
I thought it was really great that you knew. Ooh, I'm going to switch to my document camera so we can look at the same picture. I thought it was great in the pictures that your mom sent that you knew that these tangent segments were congruent. And so to solve those equations, all you had to do was set one length equal to the other. So I see in problem number 2 where you had 4x squared and 16, you said, okay, tangent segments are equal to each other, so I'm just going to do that and solve for x. And you got x equals 2 and not plus and minus 2, just 2 here because x, well, couldn't x be a negative number? Yeah, I think I'd like x plus and minus 2 here because x isn't part of the side length, but x squared is. So negative 2 could be squared. So I thought that was great that you knew that. I also noticed that you were comfortable saying, um, like in number one, that you've got a right triangle here. Um, and you're going to use the Pythagorean theorem to help you with that right triangle. Um, this is R and 8 and 16. Um, but uh, yeah, and then you set this up fine by saying, okay, R squared plus 16 squared equals hypotenuse squared, R plus 8 squared. And then the rest of that problem was done great. But I was surprised though, because when I looked at the second page of problems that mom sent, um, there's another one just like this, problem number 9. And there was no attempt on that one. And likewise, problem number 10, where all I had to do was set those tangent segment expressions equal to each other. 3x plus 6 equals 5x minus 4. There was no work there. And so I was wondering, can you tell me what happened? Was it that you got stuck on those other problems in between and then just stopped? Or you just copied the answers for the first two and didn't really understand them, so you couldn't apply it for the last two? What happened?
Well, like I think like for the first problems, mostly my sister helped me,
Ah.
and then I would like, and then for the other ones, I just couldn't um quite apply it the same way.
No, and that's because the ones 4, 5, and 6, 7, they're all different than these first two types of problems. So let me just back it up then and say, do you have any questions on doing problems 1 through 3?
Um, I sort of get it better. Um, I think just remembering how to set up the equation is
Uh-huh.
a bit
So
tricky.
in this type of problem where we're talking about tangent segments, the thing we know about tangent segments is that they are congruent. And
Right.
that, because I know that tangent segments are congruent, I'm just always going to set this length equal to this length. So when I see that in in problem number 2, I'm looking at, okay, this tangent segment is equal to this one. So 16 equals 4x squared. What would the setup be for, what would the setup be for this one? Number 10, where we've got tangent segment, 5x minus 4 and 3x plus 6. What
Uh,
equation could we write here?
5x minus 4 equals 3x plus 6.
Yep. And then where would you go from there?
I would add 4 to the other side and
Nine.
subtract 3x to the other side. And then divide by 2 on both sides.
Perfect. And so we get x equals 1. And since they weren't asking us how long this segment was, they just wanted to know what x was equal to. We know that x is equal to 1. It sounded like you're really confident with the algebra skill component of this problem, and that maybe you just need a little more time with your theorems and postulates.
Yes.
I will tell you, in the 15 years that I taught geometry, yeah, it's the class that I would always suggest using flashcards, because to me, geometry was a lot more like learning a foreign language. than
Mm-hmm.
algebra class. There were so many of these things that if I don't know them really, really well, I look at the problem and I have no idea what to do. So I might suggest, if this has sort of been an issue for you, make flashcards for every theorem, postulate, definition, where you put a picture of it on one side, and on the other you explain what you're supposed to know. Uh, that's just a recommendation. Okay, so then what about I don't see any work for number 3, and so I'm wondering if you can help me with some work for number 3 to get that answer of 7 units.
Yeah, for number 3, I had it on a separate paper,
Uh-huh.
and so um, I set it up as 18 plus r squared
Very good on having all of that stuff squared together. Nice.
equals r squared plus 24 squared.
Nice. Good. And so here, um, did you foil?
Yeah, and so on that I always make like the mistake, but um I learned that I had to do 18 plus r and then times 18 plus r.
That's exactly it. Boy, I've got seniors in pre-cal who still don't have that. So good job, you. Okay, so if we do that foiling, we get to here. Where do you go next?
Um and so oh wow, okay. Um I I combined the numbers, so 324 and 576.
And so what did you end up when you were done combining them?
I ended up with 36r equals 256.
Nice. Very good. And so, is that, I guess I can take a 4 out of each of those. 64 over 9 would be my R.
Oh,
Wait, that wasn't
oh,
that you got.
I think. Oh, it was 252.
252. 576 minus 324. It is 252. Thank you. And that does go 7 times. So that's smiley face. All right. So with that in mind, are you comfortable taking a look at problem number 9?
Yeah, I'll solve it. Okay. Um, so okay. So r plus 6 squared
Nice.
equals 12 squared plus r squared.
Very good, Gina.
And then r plus 6 times r plus 6, which would be r squared plus 6r plus 6 plus 36. Squared plus 36 equals 12. 12 squared plus r squared.
Nice.
And then okay, it would end up being 12r equals 4, 8, 108,
Nice.
and then divided by 12, r would equal 9.
Perfect. Great job, Gina. So do you feel like you can do those now?
Yes.
So I'm going to say that's the kind of thing like where you fought for understanding and you got comfortable with it, that if you don't sort of like own that knowledge, like put it in your notebook, write it down. Ooh, this is what I didn't understand when I first learned it, kind of note to yourself, then you'll probably forget it again. I'm very sad when students work so hard to learn a thing and then they forget the thing. And so I would encourage you to write that down in your notes if it's not already there. And if it is there, then I want to say, you know, another success strategy is actually reading your notes before trying to do the homework. There's one last type of problem that you seem to have difficulty with, and it was a situation like this where you had two tangents, but now instead of talking about these tangent segments, you were talking about an angle and you were talking about some arcs. So let's call this B, C, and D. Okay, so in this situation, what I know is angle A is half the difference in the intercepted arcs. And what I mean by that is this arc is intercepted and this arc is intercepted. And I want the difference between these intersected arcs. So I'm going to write the measure of arc BDC minus the measure of arc BC. There's the difference in the arcs. I want half of that to figure out what the measure of angle A is. So if we take a look at problem number 4, I think. Let me get that picture open again. Yeah, 4. I know that this arc here is 243 degrees. I need this arc because they're asking me how big is this angle. Well, they haven't given me this this arc here. This is the number of degrees in this arc. How many degrees are there in the whole circle?
I think 360.
I think that's great. Good job. So if I take the whole amount, 360, and subtract the 243 that I know, I get 117 degrees. So this arc over here is 117. And what does,
Oh,
yeah, go ahead.
oh, okay. I got it.
So my recipe for finding the measure of angle A is to do the subtraction between these two arcs and then multiply by 1/2 or divide by 2. So 243 minus 117 times 1/2 will be the measure of angle A. Oh, my handy dandy calculator, 243 minus 117 is 126. And so I get 63 degrees. Any questions about finding that?
No, it's actually simpler than what I thought it would be.
Oh, great. I'm always happy when I can provide some help that turns out to be simpler than what they were afraid of. Okay, so let's take a look at these other ones and see. Number 5, they've given me the two arcs. I just need to subtract and divide by 2. What about for number 6? How would you do 6?
Um, would I do the same thing
Uh-huh.
by subtracting by 360?
So yeah, walk me through that. That sounds good.
Okay. Um, I did 360 minus 136, which would be 224.
Nice.
And then I would set up my equations so that it would be 1/2 time, or yeah, and then 224 minus 136
Nice.
equals the yeah
Measure.
angle, yeah, measure angle 1. So then if I subtract 224, let's see, 224 minus 136, 88.
Nice. And so is that our answer? Is angle 1 88 degrees?
No. So then divided by 2
Perfect.
would be 44.
Nice. Good job. Okay, so then I think that takes care of most of them. The last one I wanted to talk about, and we can certainly talk about the others, but I'm looking now at the first problem, number 7.
Okay. Oh, yeah.
Like it's the same rule, but some students, when they go from number angles to algebra expression arc measures, they get very concerned. So how would you handle this situation? This is 61 degrees. This is 4x minus 1. And this is 10x plus 1.
Um, okay, so I think it would be 1/2 and then 10x plus 1 minus 4x minus 1 equals 61.
Yeah, now I want to say something that is a huge common mistake place. I'm subtracting all of this stuff. I
Oh,
have
yeah.
to distribute that So I should end up with +1. And that's the kind of thing where if I'm not careful, I'm going to lose a bunch of points for a bunch of years. It's really quite a common thing. So when I think about subtracting a thing from a thing, I have to make sure I'm subtracting all of this, which is why I actually put the parentheses in when I do it. Any questions about that?
No, but I did not catch that.
Yeah, but shh, that's okay. That was called learning. It's if you make that mistake again where I get to mock you. And again, so I would say, that's certainly something to write down in your notebook. Um, Remember when we were looking at this problem a few minutes ago, and you correctly knew that you had to FOIL here. And a lot of people don't know that. I think that's a great thing to put in your notes as a reminder, because even if you know it now, you might forget it by the time you get to a test or a quiz. So things that are common mistakes, I encourage people to put in, as well as things that they struggled with. And this thing about subtracting all of it fits into that category. So how does this tidy up? What do we get for a value of x here?
um okay, so it'd be 6x
Uh-huh.
plus 2
Nice.
and then 1/2 of that. So I'd get 3x plus 1 equals 61.
Nice.
And then minus 1 on both sides.
Mhm.
So then 3x would equal 60 divided by 3. And then x would equal 20.
Perfect. Good. And that's all we were asked to find there. So when you look at those other problems that you skipped, 4 to 8, look at them now and see if you feel like you're able to do them or not, or if there's some you want to look at together.
Well, I'm gonna try to solve it right now.
I think that's fabulous.
Okay.
And which one are you going to solve?
Number 5.
5. Okay.
Okay. So,
I'll do it too, and then we can compare answers.
okay. Sounds good. I got that measure 1 equals 75 degrees.
Perfect.
Okay. And then number 8.
Mhm. Which I think is a really funny question to ask a student. And after you're done doing it, I'm going to ask you why I think it's a funny question to ask a student.
Okay. Okay. Oh, wait. Okay, so oh, does 48 equal 48?
Isn't that interesting? So,
Yeah.
um, so what I think is, if I do this problem the long way, um, I have to think, okay, I know if this arc is 228, then this one has got to be 360 minus 228, which is
Right.
132. So if I put my 132 here, I then do this subtraction. I get 228 minus 132 times a half equals 48. Or, as you said, doesn't 48 equal 48?
Yeah.
The answer is yes, of course. Remember, what was it that we were asked to do? We were asked to find x. Isn't that x? Aren't we done here?
Oh,
Right. So um, now I'll tell you that when this problem is given to a student, what's expected is not what you and I would do, which is really fast and easy, but instead, the expectation, I think, is that we do this.
right.
And so if I multiply both sides of the equation by 2, and then if I subtract 228 from both sides, I get that negative x equals negative 132, or x is 132. Now, I can do the problem that way. It's just so much longer than simply saying, oh, if I need this arc, I just know 360 minus that arc will give me that. Right. So it's okay to be thinking about what you're doing instead of just sort of not thinking and just going along and doing the thing. Do you know what I mean by that? Like actually not sort of being the machine that doesn't think about it and just does a process. Instead, what am I looking at here? Oh, I'm looking at these two arcs. Oh, well, I know the difference of them is that half of the difference of them is that angle. Oh, but wait, I have to find this one. And I know that 360 minus the given one will give me that. So yeah, long approach and shortcut.
Yeah, yeah, wait. And so would my answer just stay as 48 equals 48?
No. What happens with that one is you're supposed to say, oh, wait, they wanted to know what x was equal to.
Oh,
You replaced x with 132 and then kept going. And that's okay. I mean, it's good to prove that x is 132. But when you get a number equals itself, that means that, yes, the stuff on the left at the beginning was really equal to the stuff on the right at the beginning. But no, that's not our answer. Our answer was simply 132.
Got it. That makes more sense.
Okay.
Okay, so um that's the end of my homework, but I don't know um if uh if there was anything we wanted to do more of.
You tell me.
Okay. Let's
Do
see.
you feel comfortable with those three concepts right now? The tangent
Yeah,
being equal to each other, using the Pythagorean theorem in that other type of problem, and here 1/2 the difference in the intercepted arcs.
I think maybe we could um try maybe a few more of the like the ones with the right triangles.
Uh-huh. I think that would be a great idea. The only challenge in it is I don't have a geometry book to pull some out. So let me see if I can find some.
Let's um
Come on, page, load. Okay, I went to get my old geometry book and I'm checking out circles. Here we go. Let's see. How about number 11? Can you see it?
um yeah. Okay. So 11, 9, 10, 11. Okay. Is that a right triangle?
Yes. Oh,
Okay.
no, not as drawn. But if you draw in the altitude, the height
Uh-huh.
of that triangle, that will also be the radius of the circle.
Oh, okay. Are you possibly able to tell me the numbers?
Oh, yeah. This is 12.
Okay.
This part out here is x.
Okay.
And each of these tangent segments is 16.
Okay. Okay. So. mm, Um. hmm. So how would I know what is my hypotenuse?
Well, can you show me um, where in this picture the hypotenuse would be? Is the hypotenuse this?
No.
How about this?
Maybe?
No. So I think what might be helpful for you is the radius and tangent are perpendicular to each other.
Mm.
And because of that, here's the radius, here's the tangent. They are perpendicular.
Oh, got it.
And across from that 90-degree angle is going to be my hypotenuse, whose length is x plus 12.
Okay. So, let's see. Okay. Okay, so x plus 12 squared
Uh-huh.
equals 16 plus or 16 squared plus um um
How big is that?
would I just put x squared?
Because that's x over there.
Oh, so like y squared.
I definitely don't want to introduce another variable here.
Oh.
Really like is if you could notice something about this here, and
It's the same?
it's the same. They're both radius. So they're both, right? Isn't that radius where I, go from the center to the circle?
Yes.
And both of those are 12.
Okay.
So to finish this equation,
I would get plus x plus 12 squared again.
no, no, this whole thing is x plus 12. But this, do you see any x here? I just see 12 there.
Oh. Yeah, okay, so it'd be plus 12 squared.
Very good.
Okay. Okay, so then I'll do x plus 12 and then times x plus 12. So then I get x squared plus 12, x plus 144. So then okay. And then hmm, um mm, okay, wait, let's see. 16 So then, oh, okay, I got it. I'd have x squared plus 24x plus 144 equals 256 plus 144. And then I'd be able to cancel out 144. So then I would just have x squared plus 24x equals 256.
Nice.
And then
If I had a quadratic, I moved everything onto one side so that I could factor or use quadratic formula.
oh, right. So x squared plus 24x minus 256 equals 0.
Uh-huh.
And then to okay.
지나, 선생님한테 얘기하고 10분 뒤에 하면 안 되냐고. 그래 봐봐. 지금 15분 남았는데 10분 뒤에 지금 8, 9:30이야. 그러니까 나 어텐드만 하고 10분 뒤에 다시 오픈해서 15분 더 가르쳐주면 안 되냐고. 그렇게 얘기해. Does it help?
Yeah.
참 녹음했니?
Yeah, that's what he's doing.
응? 녹음했어?
Yeah, that's what the 성수님 is doing.
녹음해서 이제 보내겠다는 거야?
Probably.
오케이. 언니가 그런데 요거 하나만 누르면 녹음이 된다 그랬어. 너도.
I didn't know.
오케이. 어쨌든 그 얘기해. 지금 학교 어텐드를 해야 되니까 10분만 있다가 내가 다시 15분 더 가르쳐 줄 수 있냐고.
Okay.
지금 45분 했거든.
Okay. Before I finish the problem, can I leave the meet real quick to fill in my attendance for my first period?
Yes, if you feel like you need to go through the rest of this and more with me, then by all means do that. If you feel like you do need more practice, then by all means, or if you don't need more practice, then by all means, hey, let's just call it an hour, and I'll see you when you next want to meet.
Okay. I think I kind of want to finish the question, so I'll probably be back in like 5 minutes. If that is okay.
Sure.
Okay. Well, I will see you in 5 minutes then.
Here. Hi, well,
Okay. I'm back.
so you were going to finish that problem?
Yes. I just with like numbers like these, I don't know how I can find the numbers quickly.
I agree completely. And I would say if you don't see them quickly, just use the Pythagorean, the quadratic formula. X equals negative b plus and minus square root b squared minus 4ac all over 2a. Remember that?
Wait, did you say something?
Yes, I said, do you remember this quadratic formula?
Oh, yes.
Great. So that's what I would do. That's going to be more. If you look at it and you don't see quickly how to factor it, jump over to the quadratic formula. It'll be much faster.
Okay. Okay. So maybe minus 24, right?
No, plus 24x. Oh, I see what you're saying. Yes, minus 24 here.
All right. Okay, and then plus or minus 24 squared minus 4 x 4
4
times,
times 1. The a value is 1 there.
yeah, 4 times 1 and then times 256.
And isn't it negative 256?
Yes.
So that minus times that minus, you're going to end up with b squared plus 4 times 1 times 256.
Um,
Tell me.
wait. Oh, okay, wait. Um, okay, so then, huh. Well,
Tell me.
so I did 24 squared
Uh-huh.
and I got 576.
Uh-huh.
And then I did negative 4 times negative 256.
Uh-huh.
I got 1024.
Right.
So if I add them together, I would get 1596.
Ooh, I got 1600. 1024 plus 576. 6
Oh,
0.
oh, yeah, I didn't add the thing. 10, 9, 10. Yeah, just 1600.
Uh-huh.
And then,
Square root of that, huh?
yeah, the square root of that, it would be like 40, I think.
Yeah.
Okay. So then 40, It's like -24 plus or minus the square root of 40.
No, you used the square root already. It's -24 plus and minus 40.
Oh, okay.
And don't forget, it's still divided by 2.
Okay. And then okay, so then I probably do -24 plus 40, which is 16 over divided by 2 is 4.
No, 16 divided by 2 is not 4.
Oh, I mean 8. 8, yeah, 8. And then -24 minus 40, I'd get -66.
-60 what?
Negative neg oh -64, right? No. I'm doing this wrong. Minus 40. So it'd be 40, 24. Right, -64.
And then don't forget, divide by 2.
Divided by 2, which would be 32.
Right.
-32.
Good. So we're going to throw that -32 out because we can't have a length of -32.
Oh, right. So then I just have 8.
You got it. That's our only solution.
Oh, wow. So 8 is our solution. So, oh, wait. Okay. And then with the 8, I put it in the equation.
No, because I thought we were just looking for what's x. Right? Remember that x part was just the part sitting outside. You found that.
Oh.
Yep, there's that. Yeah. Remember we had this picture. And this here was our x. And this was double. And this here was 16. And at first you weren't sure, but you realized that both of these were radii. So that would be 12 as well. So yeah, the only thing I'm looking for here is how big is x? And you just found that. You said x equals 8.
Oh.
You need another one like that?
Yes.
Find x.
Okay. So I would do 6 squared.
Well, remember that 6 is only this part.
Right.
The whole hypotenuse before I start talking about squaring.
So, well, I can't add another variable. And so then I would
Call the length from the center to the edge of the circle. What's
the radius.
Yeah. And what do you notice over here?
Oh my, yeah. It's the same thing.
And that's why I would say this is going to be a great thing for you to write down in your notes, because this is also the radius.
Yes. Yeah. Okay. So then, so I could just add 6 and 9 together.
Yeah.
No.
That'll be 15.
Yeah, so 15 squared equals 15 squared equals x squared plus 9 squared, and then 15 squared. Let's see. 225 equals x squared, whoops, plus 9 times 9 is 81. So I would subtract 81 on both sides. Four, two, four. 144 equals x squared. And oh, I get it. And then to undo the x squared, you take the square root, and then you'd get 12 equals x, or x equals 12.
There it is.
Okay. Okay. I guess that one wasn't too bad. I just yeah, I just have to watch out for that radius part.
I was thinking the same thing. So I would say either write this in your notes and then have a wonderful day, or we could do another one and then have a wonderful day.
Well, do you know how much time we have left?
Time we have left, you and I.
Yes.
I'm still on the quarter hour. So how much time do you need? We're at an hour and 15 minutes. An hour and 15 minutes right now. So we can keep going. If we need to keep going, we can stop. We can do meet another time when you have more questions, whatever works for you. I believe you're supposed to be in class right now.
I guess we could meet on another session.
And do you want to set one up now, or just let me know a little more than 24 hours in advance when you'd like that to be?
Yeah, hold on, I'll actually just bring my mom. Yeah, 끝났는데 next 그거를 지금 셋업하고 싶은지 아니면
셋업 해놔서 항상 필요하면은
Okay, so
필요하면 이제 너도 들어 좀 가끔 해야지 이런 식으로. 그래서 녹음한 거 완전히 다 끝났니?
no, we're still here.
오케이. 그럼 셋업해서 다음에 필요할 때 엄마야? 아니야? 지금 그렇게 해달라 그래.
So 다음에는 그냥 다시 연락하겠다고. Okay. So I think for our next lesson, I'll let my mom know 24 hours in advance, and then I think we can set another meet up the
Great.
next time.
I strongly recommend flashcards, and I definitely think about radius.
Yes.
Yeah.
Yes.
Was this helpful, Gina?
Yeah, it was actually super helpful.
Great. Well, let me know when I can be of help, and I'm happy to be there.
Okay, thank you so much. And, I see that you were recording this lesson.
Yeah.
Is there a way to share the recording with me?